Interpreting the effect of LK norm with different orders on training machine learning model with the presence of outliers. Both the runs and the may are ways to measure the distance between two vectors, the vector of predictions and the vector of target values. Various distance measures, or norms, are possible. Generally speaking, calculating the size or length of a vector is often required either directly or as part of a broader vector or vector matrix operation. Even though the norms is generally the preferred performance measure for regression tasks, in some contexts you may prefer to use another function. For instance, if there are many outliers instances in the dataset, in this case, we may consider using mean absolute error, may. More formally, the higher the norm index, the more it focuses on large values and neglects small ones. This is why IMS is more sensitive to outliers than may. Source: Hands-on Machine Learning with Scikit-learn and TensorFlow. Therefore, ideally, in any dataset, if we have a great number of outliers, the loss function, or the norm of the vector representing the absolute difference between predictions and true labels, similar to y_diff in the code below, should grow if we increase the norm. In other words, IRM should be greater than may. Correct me if mistaken. Given this definition, I have generated a random dataset and added many outliers to it as seen in the code below. I calculated the LK_norm for the residuals, or y_diff for many k values, ranging from 1 to 5. However, I found that the LK_norm decreases as the value of k increases. However, I was expecting that norms, aka norm equals 2, to be greater than may, aka norm equals 1. I would love to understand how LK norm is decreasing as we increase k, aka the order, which is contrary to the definition above. Thanks in advance for any help. Code. Output. Finally, I would love to know, in which cases one uses L3 or L4 norm, etc.
Another Python implementation for the np.linealges. To test our function, run the following. Output. Therefore, we can see that the numbers are decreasing, similar to our output in the figure posted in the question above. However, the correct implementation of RMS in Python is np.mean np.absArray k, 1/k, where k is equal to 2. As a result, I have replaced the sum by the mean. Therefore, if I add the following function and run the following, output. Hence, the numbers are increasing. In the code below I rerun the same code posted in the question above with a modified implementation and I got the following. Output. And that explains why the loss increases as we increase K.
To answer your question, we first have to look again at the LP norm, how it is defined and what does it mean in the limits. The definition of the LP norm is as follows. You correctly identified that if p equals 1 you have the sum of absolute values, and if p equals 2 the sum of squared values. There are two special cases, p equals 0 and p equals infinity. For p equals 0 the LP norm essentially counts the number of non-zero elements in the vector x, and p equals infinity returns the maximum absolute value of the vector x. What does this mean in terms of fitting a model, for example a simple line as you did? As you correctly stated, the higher p the more emphasis is given to outliers. L-infinity loss would try to minimize the maximum absolute error a regression model would make. That means even a single outlier would completely influence the parameters of the fitted line. In contrast, the L0 loss would try to minimize the number of non-zero elements. That means the optimal model would try to have as many points directly exactly on the fitted line, a zero error, as possible. Here's an example with where you can see the effect of different LP norms as loss function when fitting a line in the presence of a single outlier. Now to your suggestion that a larger p would mean the norm of the error vector y_diff would increase. That is only the case if you omit the pth root in the norm definition. I adapted your code and plotted p versus the LP norm of y_diff and the pth power of the LP norm. You can see that if you omit the pth root in the norm, your intuition is right. However, if you include it, it will converge to the L-infinity norm, which is the max absolute error, for larger p. Since L-infinity will ignore all errors but the maximum one, that's why it is decreasing. Code.
If you want to see more, please consider subscribing.